Welcome, everyone. My name is Vishesh Oberoi, and I'm a principal product manager on the Azure Communication Services team. Later on in the session, I'll be joined by my colleague, Jason Shave. And today we'll talk about how to build custom communication workflows for delightful customer experiences using Azure Communication Services. Over the last couple of years, we've seen a major transformation in how employees connect with each other and the business itself. And similarly, we've seen how that's affected how businesses interact with customers as well. Our experience as customers, that I'm sure all of us can vouch for, has been filled with long wait times on customer support calls. And while customers still need to connect to businesses for a variety of reasons, there's an emerging trend of expectation from customers who want to be served through their preferred channel of communication. A key priority for every business is to ensure that they optimize their business processes that effectively leverage their finite workforce. And lastly, a key part of serving customers is to ensure that the business adapts to their needs and derive insights from the constant monitoring of sentiment, satisfaction scores, and analyzing conversations. And Azure Communication Services has helped many businesses in a variety of scenarios. For example, LinkedIn launched native video meetings for its web and mobile users last year to make professional conversations more personal. We have partners in the health and life sciences sector that are using voice and video and chat to transform clinical care with more intuitive virtual appointments. And lastly, we've helped several retail customers bridge communication gaps, whether that's providing real-time virtual assistance or enabling remote interactions like curbside pickups. Azure Communication Services provides a variety of core capabilities such as voice and video calling, chat, telephony, SMS, and email. Our APIs make it easy for developers to directly integrate all of these services into their mobile apps, their desktop applications, website with just a few lines of code. Developer-friendly APIs and SDKs make it easy to create personalized communication experiences quickly without having to worry about complex integrations, and these capabilities can be virtually used on any platform or device. For example, you can leverage our globally scaled voice and video calling to build interactive person-to-person interactions for telehealth use cases or telebanking use cases that are picking up a lot of momentum that was exacerbated by COVID. In addition, you can build chat experiences that are deeply embedded into your existing applications. And for the first time ever over the last couple of years, developers have been able to acquire phone numbers, whether those are geographic local phone numbers or toll-free numbers directly from Azure, or integrate their existing customer service systems over SIP trunks using direct routing. Customers have been able to leverage SMS and email capabilities to reach out to their customers on their preferred communication channel as well. Azure Communication Services provides a variety of these core services that we've just looked at. Through these core communication channels, you're able to reach your customers wherever they are. And through our APIs and libraries, developers are able to leverage these building blocks to integrate into their existing customer experiences, whether that's using our client SDK to build sophisticated WebRTC-based applications, or whether that's leveraging our reusable UI library that makes it easy to leverage explicit UI components and embed them directly into web and mobile experiences. Our programmable APIs and flexible SDKs make it easy for you to integrate all of these services and capabilities directly into your existing customer service systems, whether that's a contact center, a CRM system, or adapting to a runtime context that customers are experiencing through their lifecycle during a communication workflow. And finally, Insight is a critical part of every business, as we've just talked about. And using ACS, you can record chat conversations, messaging conversations, leverage call recording, which is available as a API as well, and leverage all the insights that have been generated throughout the customer journey to comprehend and ensure that you are able to continually improve your customer experience over time. I'm excited to announce the public preview of Azure Communication Services Call Automation that provides developers the ability to build server-based calling workflows using a simplified programming model that integrate with your existing customer service systems to deliver a much more personalized customer experience. Whether that is to manage bookings or reservations, to send voice alerts, deliver click-to-call experiences directly from your web or mobile applications, or deliver a superior customer support experience. Using call automation, developers can build workflows that help them boost the agent productivity in their business by deflecting customer calls for simple self-service calling scenarios. Developers can use ACS client libraries and UI libraries to embed calling experiences directly into their applications. That makes it easy to not just embed those calling experiences in their applications, but also reduce the telephony spend. In addition, with click-to-call experiences, you can extract the specific context that is available on that web page or in that mobile UI that might be relevant to help agent in assisting the customer through that journey. And finally, when we think about delivering a superior experience, more and more customers are looking to proactively reach out and alert customers about an upcoming outage, reschedule in flight, or whether that is to talk about and present information that might be relevant at that point in time. A canonical solution architecture using Azure Communication Services is about reaching your customers where you are. So if you think about a customer, they could be using an SMS channel, chat channel. They could be on a website, or they could just be picking up a phone using our PSTN functionality. This high-level architecture demonstrates how a customer call is handled via ACS and Contoso's app, which can be routed to various endpoints, including a virtual assistant or a contact center. Using call automation APIs, developers are able to receive an incoming call, make an outgoing call, and really comprehend the customer experience and support them throughout their entire life cycle, whether that is through leveraging our play and recognize actions that is available directly in call automation APIs, or to add in additional virtual agents or additional subject matter experts, or just transferring to your contact center as well. Through this public preview, our primary focus has been to ensure that we provide a superior programming model, and that is through an event-driven, action-based programming model that makes it easy for any developer to embed communication actions directly into their application without being an expert in telephony. Control plane actions, such as being able to make an inbound call, outbound call with ease, makes it easy for developers to answer, reject, transfer, and resume calls. Through our participant management, you're able to manage the roster and who is on the call to support a variety of scenarios. And through this public preview, developers are able to program VoIP or PSTN calls for transactional workflows such as click-to-call and appointment reminders to improve customer service, or build more interactive workflows for self-service using our play and recognize actions at the data plane. Using control plane, developers can easily use our make a call action or receive an incoming call notification to answer, reject, transfer, or hold. In addition, all of these APIs are fully interoperable with our direct routing and direct offers that are available for developers to configure in the Azure portal to integrate with your existing contact center as well. Through some of these initial data plane actions, such as play and recognize, developers are able to play a pre-recorded message and recognize input using DTMF tones. In addition, through our extensive roadmap over the next couple of months, you'll notice additional capabilities, such as being able to interop with Microsoft Teams, or enhance the play and recognition APIs using Azure Cognitive Services, whether that's through speech to text, text to speech, and so on. And so now I'll hand over to my colleague, Jason, who'll walk us through a customer journey around notifying a customer about an upcoming flight change. So Jason, over to you.
All right, thanks, Vishesh. My name is Jason Shave. I'm an engineering manager in the Azure Communication Services team working on call automation API and SDKs. We're showing you an exciting demo on how we're going to notify a customer about a flight change using an automated application. So we have two components here. There's an outbound dialer that's going to be calling May, which will be me. I'll be picking up the phone. We're going to hear some audio played. I'll end up pushing 1 to get my flight options emailed to me. And then for the next menu option, I will listen to my options available, which is to have an alternate email address supplied. I'll skip that option. We'll hear another message, and then the call will end. And with that, I'm super excited to walk through this code showing the call automation API. Okay, let's start off by looking at some of the resources we need in Azure in order to get this demo working. So first, I've provisioned a speech service here. This is really just to enable the text-to-speech and the creation of my WAV files a little bit easier. The star of the show and the thing I'm most excited about is Azure Communication Services. And so I've provisioned my resource here. Then lastly, I have a storage account that's going to hold my WAV files for my IVR experience. So let's look at that Azure Communication Services resource. I've highlighted the keys section here, and specifically I'm after the connection string that I need to both enable my outbound dialer as well as my inbound application. I've also provisioned a phone number for inbound and outbound dialing. And then I should also mention that we do enable inbound PSTN calling through Azure Communication Services. I can choose different schemas here. I can choose a cloud event schema or an event grid schema. I can choose the different events I want to subscribe to. If I was doing inbound calling, I would subscribe to the inbound calling event. I would receive that perhaps in a webhook, my web application, and kick off my workflow. Okay, so now that we have our resources provisioned, let's look at the WAV files, how we generate those WAV files using Azure Cognitive Services. I'm going to pull up the PowerPoint deck again here and just review what it is we need to have happen. So there's an outbound call that needs to happen here. We need to place some text, provide these options. There's also a second level menu option that we'll need to display or have audio played through to the caller. And then last thing here is there's a final wrap-up audio file that needs to be created. And I've used Cognitive Services here to create those. Here's the flight options. Here's the hi there, I'm Kai message. I can export this to a WAV file. I can then import it into my storage account, which is here. And in my storage browser, I have my blob container with my IVR folder, and I have the 3 files I need for my menu. So I think I'm set for the audio files that I need. I have all the resources. And one thing we have to do is review our requirements to meet the need here. So from a programming perspective, the requirements here for a Datum Airlines is that when the call comes in, we want to watch for this event called call connected. And as Vishesh mentioned, super excited about the architecture that we built here, which is kind of a request, response, and event model. So we'll see this call connected event come through. We're going to play that top level menu prompt, allowing the user to press 1, the DTMF tone. We need to be able to detect that DTMF tone and then invoke the recognize API. That's going to recognize whatever DTMF tone is pushed and then invoke a second level menu. Now, with each of these events, the recognized completed or recognized failed events will need to be picked up. We'll need to check the context and ensure that the right menu or the right DTMF tone is linked to the right subsequent code in the workflow here. We also want to watch for a play completed event and then hang up the call. I have a last option here, which I'm going to do some live coding and show you that the solution that we have isn't entirely complete, and we'll get to that in a second. Okay, the first thing I want to show is the outbound dialer. So in Visual Studio, I have 3 projects. I have a call handler, an enhanced call handler, and an outbound dialer. The first application we're looking at here is the outbound dialer. This is just a console application. I have configured in my user secrets file the connection string that I grabbed from Azure Communication Services portal. I'm creating a call automation client. I'm setting the callback URI, which is where I'll receive those events when certain actions are invoked. In this particular case, I'm just creating a new random GUID value. I'm also setting the source ID, which I get from my user secrets file, creating the call source, setting up the target that I want to call to, which is going to be my cell phone number. Make this a little bit bigger as well so you can see the rest of the screen. And then here's where we create the call. So you can imagine some process that you might have in your business workflow that would take these parameters dynamically, use the call automation client, and place the outbound call. And then lastly, we'll echo to the screen the fact that we're making that call. Okay, the second thing I'm going to show is the web service. So this is our call handler application. We have a program.cs file. We're using .NET 6 minimal APIs. This is a really great developer experience. Some people, like the idea of minimal APIs. I'm certainly a big fan. Makes things really easy to read. I don't need to worry about setting up different controllers. Basically, I've got this inbound post action here where I'm going to catch those incoming call events. I need to then perform some actions or kind of interrogate what's happening with the payload and perform certain actions. So let's look real quick at what's happening here. We're using the HTTP request pipeline to read the content and serialize it into a collection of cloud events. Now, these cloud events are the Cloud Event Open Standard that's available in both Event Grid, but we use it in Azure Communication Services call automation as well. We send this collection of cloud events, we read from JSON, we get this object collection, and then we iterate through those. The team has done some great work in providing an event parser here to get around some of the challenges that customers might have in parsing their own data. We give it the cloud event, we serialize it into a particular C# class, and from here we can start to interrogate what type of event is this. So in the case of the call connected event, we are going to invoke the recognize API. The recognize API takes a set of recognize options. We're going to collect one DTMF tone. We'll allow for interruptions of the prompt. And then here is that file source where I saved into my storage account that cognitive services wave file that I created using that tool. Another important factor here is that I set the flight options to be the operation context. So this is, you could call this maybe the top level menu, but I called it flight options. We'll use this a little bit later to stitch together the experience of the person pressing 1, receiving the recognition on the DTMF tone, and then invoking the next flow. So with that, when we receive this call connected, we'll return the results back, and that component ends. Now, once you push 1 on the DTMF, or 1 for the DTMF tone rather, you will, the system will end up calling back into the web server. We'll see a recognize completed event come through. And we want to check and see and make sure that the operation context matches that flight options that we set on the previous operation. So this is how we're stitching together action 1 to action 2. As we described in the demo, so I'll come back to this real quick, we're really at this step here where we've played this message, we've pressed 1, and now we want to play the second level message. So here's where, again, we have the same DTMF recognition. We're asking the caller if they want to supply alternate email address for the flight notification information. And in this case, we're setting the operation context for this level of workflow to the optional email change. Okay, so if by chance I ended up pushing 1, and I don't have the code for this for the sake of clarity here, just to say if I was to push 1 and the operation context was that same previous 1, we are then also recognizing a DTMF tone of 1 in that same context. And we would use a future feature here that will have to capture the speech and allow the caller to specify their own email address over the phone. Okay, now the last thing we have to fulfill here, if I go back to my requirements, is that if the person does nothing, so you press 1, then you're going to invoke that other workflow. If you do nothing, we need to fall back and simply play audio. So this invokes the play audio API. We're going to play this particular exit message, I guess you could say, where we say, okay, that's all. I'll send you a short survey. Have a great day. Goodbye. Now, I did mention on the requirement that we're missing one step here. So when play is completed, we have to hang up the call. But we don't see a play completed event here. So I do need to make a change. So I'll say if event is play completed, we'll call that play completed. We want to await our call automation client. We'll get our call connection, supplying the event call connection ID. And I'm going to hang up async. If that works. Oh, and there is a Boolean flag on this. If I use IntelliSense, I can see for everyone. And yes, I'm going to hang up for everyone. Okay, so that means that when the audio is done, we'll finish up and wrap up the call. All right, let's look at the live demo. So I'll make an outbound call. All right, here's my outbound dialer. I'm going to run my .NET run. And I will wait for the call.
Hi there, I'm Kai, the intelligent virtual agent from Adatum Airlines. I wanted to inform you about your flight change next week. If you would like to get your flight options emailed to you, press 1. If you prefer for me to tell you your options, press 2. To speak with an agent, press 3, and to hear these options again, press 0. Thank you. I'll send your flight options to the email address we have on file. If you prefer for me to use a different email address, press 1. Okay, that's all. I'll send you a short survey so you can share your feedback. Have a great day. Goodbye.
Okay, and then the call ends like we've programmed it to. Okay, that concludes our demo. So as we showed, we were able to make this outbound call and notify the caller of the scheduled flight change and have their options emailed to them. We facilitated this through the various APIs that were available. So we made an outbound call, we were able to answer it, and then follow this workflow back and forth. We were able to detect DTMF input, potentially interrupt that input and respond to the corresponding event so that we didn't have to wait till the audio finished. We were then able to terminate the call at the end of it. And optionally, if we wanted to start the recording APIs are there as well. With that, I'll turn it back to Vishesh.
Thank you, Jason. So what you saw in that demo was to effectively make an outbound call and carry out a series of actions to deliver a customer experience. That same customer experience can also be embedded in your web and mobile application as well using our WebRTC technology, whether that's on web, on iOS, or Android. And the rest of the workflow remains exactly the same through our APIs and libraries. Azure Communication Services is interoperable with the rest of the Microsoft Cloud portfolio, whether that's through Microsoft Teams, through Power Platform, Dynamics, or the most recent addition to our portfolio with Nuance. Customers use Nuance Mix to build complex conversational AI workflows. And soon, you'll be able to leverage Azure Communication Services to expose your Nuance Mix conversational AI workflows using Azure and Azure Communication Services for messaging or voice channels. Over the next coming months, what you'll see is within Nuance Mix, you'll be able to dive right into your conversational agent, select your preferred experience or your conversational AI app, and choose what all channels from Azure Communication Services you want to expose it on. For example, in this case, I'm leveraging Azure Communication Services PSTN services, where I'll plug in my couple of details, my client ID and secret, and that'll give me access to a phone number that I can now expose this conversational AI experience on. When I attach that conversational AI experience to that phone number, I'm able to just simply lift up my phone and make a phone call.
Windborne Airlines. Thanks for flying with us. How can I help today? or say what are my options.
And just like that, within the next few months, you'll be able to leverage Nuance Mix with Azure Communication Services. Finally, to learn more about everything I've talked about today, follow a couple of our links to dive right into the documentation that's available on Microsoft Documentation, as well as the code samples that were demonstrated through Jason's demonstration. With that, we're excited to see what you do with call automation and Azure Communication Services. So thank you.